Guys, welcome back to Consistent Code. So today's problem of the day is Tom and Jerry. So basically, we are given an integer n, and there is a game in which Tom starts playing first. So what happens? Suppose you're given an integer 2, or you're given an integer, let's say n. Then what you need to do? There are three things. The first thing is that Tom needs to play first. Jerry will be playing second, and you need to subtract any divisor of n from n. Suppose n is 2, then if Tom is playing first, Tom plays first, and so what can Tom subtract from n? Tom can subtract 1 because 1 is a divisor of 2. 2 is also a divisor of 2, but the divisor which you choose should be less than the number itself. Hence, you have only one choice. You choose 1. Hence, the number becomes at minus 1. That is 1. Now, when this becomes 1, it's Jerry's turn. Now, Jerry cannot choose any divisor for 1 because 1's divisor is only 1 and you cannot choose the number itself as its divisor. Hence, Jerry loses and Tom wins. And you can see the output as 1. And if Jerry wins, we have to output 0. So that's all which what this question needs. Okay, now how to solve this question? Just observe something. If n is 1, you can see that in this case, who wins? Obviously Jerry, because Tom cannot make any move. Now, consider n as 2. Now, think who should be winning. The only divisor which we can choose is 1. And observe one more thing, that 1 is divisor for every number. Okay, now when n is equals to 2, then Tom will win. Now why Tom will win? Because as n is 2, so what can Tom choose as a divisor? Tom will choose 1 and subtract 1 from 2 and make it to this condition n equals to 1, where Jenny was winning. But now Tom will take advantage and Tom knows that if n was 1, then Jenny was winning. So Tom subtracts 1 from this and makes himself win because it's like now when n is 1 and Jerry is starting first, then Tom will win always, right? So similarly, you can consider n as 3. Now what can Tom do? Since n is 3, so Tom has no choice but to remove the divisor 1 only. So this converts n to n minus 1, that is equals to 2. Else you are again in this condition. Now Tom, when n was 2, Tom was winning. But now Tom has reduced n equals to 3 to 2. So now it's in Jerry's favor. So Jerry should be winning. Similarly, if you will consider n equals to 4, you will find that Tom just needs to see in the previous condition, like if n was 3, then Jerry was winning, right? But now, since Tom wants to win, what will Tom do? He will reduce this even number by 2. So he will win. So Tom will win in this case. So if you make this pattern for n equals to 5, for n equals to 5, we will observe that Jerry wins. And this pattern continue. So what can we conclude? That if n is odd, then always Jerry wins. And else Tom will always win. So this is what we can conclude from this. Now we need to answer something. Now how to check if n is odd? This can be done just by one line, n and 1. Let's check if n is odd. Right, we can simply return n and 1. This will return 1 if n is odd, and it will return 0 if n is even. But if n is odd, then it returns 1, right? And if n is odd, then Jenny wins. But if Jenny wins, we need to return a 0. So we need to return 1 minus n and 1. Why a 1 minus? Because if n is even, we need to return term which that is 1. So if it is even, this n and 1 becomes 0, and 1 minus 0 will be 1. And if n and 1 is odd, that is n is odd, then 1 minus 1 will become 0. So this basically is inverted. If it n and 1 is 0, then we are returning 1. If n and 1 is 1, we are returning 0. And that's exactly what we need to do. Now let's just submit this code and say this is working for all the test cases. So it's working for all the test cases. And I hope you like the explanation. And if you did so, make sure you hit the like button and subscribe to the channel for more such content, because it motivates me to create more of such content. And I will see you tomorrow with the next problem of the day. See ya.